In a broadcast and non-broadcast multi-access network, OSPF is assigned a priority value of 0 to 255. So we have to remember that, because this is important when it comes to designing an OSPF network, that there is a priority value on the interfaces, and those interface priority values are assigned 1 as the default value. And you can manipulate this value by increasing it up to 255. The reason why I'm saying is that if you have a switch, and in a switch you have multiple routers, let's say R1 and R2, and you know one of these routers is stronger than the other one, it's bigger in terms of hardware resources, and it can handle all the updates and do link state advertisements to all other routers in the network, then you need to make sure, like, this router that is your DR has an interface priority of 255 or something that's higher than the other router interfaces, and that's what the selection process will be looking at. So number one, the router with the highest priority value is elected as a DR. Right? So this is the command that you will use on the interface to increase the priority value for the router that will be your DR. So I'm assuming this is the DR and this will be your BDR. So if you put priority of 255 for this one, then you can put 254 for this one. Now in case there is a tie between the two routers and the priority is the same, the router with the highest router ID becomes the DR. So again, it's the same concept. That's the second step. Like if you do not give a priority to these interfaces and they're already 1 on both of them, that's a tie. And then the OSPF will look at the router ID, and if the router ID on this one is set to higher than R2, then this will be the DR. And basically it's very simple. When you give the command router OSPF 1, you can immediately assign a router ID, right? And let's say you assign it 100.100.100.100, and you know that this router ID will be the highest router ID in this router in the network, and this will be basically your DR then. And the router with the second highest router ID will become the BDR. And if there's no router ID assigned, the routers with the highest loopback address is to be used. So most of the routers in the production networks will have a loopback address, and those loopback addresses are supposed to be configured in the routers for good practice, because the loopback IP addresses are always up and they never go down. So that's very important to remember. Let's say you have a third router, and the third router is there, but it doesn't want to participate in the DR BDR selection process. Then you basically give it a priority of 0. You assign a priority of 0 to the interface, and this way this router will not participate in the DR BDR election. So I hope that's clear. The other important point to understand is when you have a DR and then you have a BDR, and this could come in an interview question basically, right? And you have other routers, let's say R3, R4, and these are basically D other. That means they are not participating in any election process. But what happens is the DR is the one that receives all the information from these routers, And also these DR others will be communicating with the BDR at the same time. And this is a bi-directional communication, but any link state updates will be done through DR only, right? So in a sense, what happens is the DR and the BDR, the DR and the BDR will be basically in touch, right? And BDR will keep an eye on DR, but all the updates will be coming through DR only. And if DR fails, then BDR takes over. I hope that is understandable. This is basically the synchronization structure of the OSPF, right? And all these other routers will be only talking to DR. BDR will be getting the updates, but it will not trigger, and it will stay silent, and it will not basically take over the role of the DR. It's the role of the DR is to maintain and update and send LSAs in the network, whereas BDR is just a silent partner where it will just keep an eye on DR. If it fails, yes, it will take over and it will start updating um, the database. I hope that's clear, and let's move to the next topic. Thank you.